ni chini bana, ukuje uendelee na hii kazi. Unaniacha hapa hivi nafanya peke yangu. Harakisha bana, wacha hiyo mambo. Haya, shika, kimbiza. Nataka tujaze hapa haraka, mbio. Hakuna kulalia masikio. Sawa. Haya, wewe. Monica ameingia hapa hivi mbele yako, unafanya nini hapo? Wacha mambo yako wewe. Oh, mmenipata kazini. Mimi si foreman. I actually don't even know what I am doing right now. Technically, the work I am here to do is totally different from what you have seen me start doing. I am here to learn about walling. Oh, yes. What is walling? Why is it important? And what are some of the materials that are used in walling? Are you looking for a partner to lean on as far as construction is concerned? Then look no further. I'm Martin Gethenji, and this is Tujenge. Build it better. Wait, tuingie kazi bana. Tufanye kitu, tumalize. I'm going to start with a question that might sound redundant. What is a wall and why is it important?
First of all, a wall is an element of a building. We can define it with the functionality of the wall. The function of a wall purposely is to enclose the building, to provide protection to the building. And then most importantly is to enclose, to create spaces within the building. If you want to have a kitchen, you need a wall to partition the space. If you want your living room, you need a wall to create the space.
At what stage should we begin the process of walling a building?
Okay, so walling in a building is divided in two sections. We have the walling done in the foundation, and then we have the walling done in the superstructure. After you've done your strip foundation, there is normally a natural stone wall done on the strip foundation up to the slab level. Before now you do the hardcore and the maram blinding. Then you do your DPM and the BRC before you now cast the ground floor slab. There is walling normally down there. That is for the foundation wall.
So wall haijaanza tu mahali tunaona?
Haijaanza mahali umeona. There is wall down there, which is normally 200 millimeters thick wide. Normally people call it the 6x2 wall, natural stone wall, beneath the ground floor slab that you see. So above the ground floor slab, that's where now we have the wall, the one that you see now. So now for walls, they can be categorized according to the functionality and their location and also the function. So according to their functionality, we have load-bearing walls and non-load-bearing walls. We have acoustic walls and we also have partitioning walls.
Okay, mimi nikiangalia building mimi naona tu kwanza hata kuna fulani ninaona huko inatumia zile bricks ni kama za matope na building imesimama. And so unaniambia ukuta si ukuta.
In a building we have the structural elements. Those are the most important parts of the
skeleton.
The skeleton. That is the most important part of a building. The skeleton structure consists of we have the beams, we have the columns, and we have the slabs now. So when now they do construction, after they have casted the ground floor slab, they normally do formwork for columns, then they do the reinforcement, then now they cast the columns, the kokoto. Hiyo wanamwaga hapo ndani. So after they have cast, they now do the shutter for the first floor slab.
At the what?
It's like a formwork. Ndio sasa for you to cast now that kokoto ya first floor, they have to do like a bed to hold the fresh concrete.
Kama ni mbao flat hivi
umekelea ndio una cast. So when you do such a structure, the kind of wall that you will do there are called non-load bearing, because we don't need the walls to carry the weight of the building. Because the weight of the building is already carried by the columns and the beams and the slabs. So there you will do non-load bearing walls. If you're going up, let's say more than 5 stories up, you cannot do a solid structure because a solid structure can only hold up to 4 floors. So when you go up more than 5 stories, you will have to do the frame, that is the columns, the beams, the slab, as you progress. Then you come and do your walls as infills. Now they just come and close the space. Then you do your finishing. But then if you want to do a building, say a maisonette, you are doing ground floor, then the first floor. You can do the ground floor, then you do load bearing walls. Then you do your ring beam on the walls. Then now you can cast the slab. But now the ring beam and that slab are normally done simultaneously.
In designing of ilukuta yenye utajenga, what are some of the most important elements that you need to put into consideration?
First of all, you have to consider the functionality of the spaces you are creating. You may need the space to be soundproof. You may need, let's say we want to partition spaces. How many rooms do we have? Yeah. So if you are partitioning, you will have different types of walls. For partitioning, we normally use 100 millimeters thick walls. Ndani ya nyumba. So when now they design, they will say, we are partitioning these spaces, let's do 100. But then externally, it is normally recommended we do 200 millimeters thick external wall.
Oh, so ukuta nje hukuwa thicker than ukuta ndani?
Than ndani.
Okay.
Yeah. So also, even if it is a partitioning wall, but then you want to achieve the acoustic functionality, utaki sauti isikike ama itoki, they make it thicker. They make it thicker, yeah. So the size of the wall varies from external to internal, but in some other situations they can be similar. Yeah.
Is there any reason why hiyo mawe umesema yenye inatumika ndani sio yenyewe inatumika nje na yenye inatumika nje sio yenyewe inatumika ndani?
The reason is, you know, when architects design, they want to create as much space as possible in the building. Inside the building. So when you do a smaller wall with a smaller thickness, you'll maximize on the space in between. But when you do a wall with which is thicker than 100, you'll be minimizing the space. But architects try and maximize the space. That is the principal concept of designing spaces in a building, maximize on the space available.
And other than that, because I'm guessing now the bricks that are outside, they are cheaper. I mean, the ones that are on the inside, they are cheaper compared to the ones that are outside because ni ndogo. So mbona nisitumie hiyo tu nje pia? Si bado ni mawe?
Yeah, it's possible, but partitioning wall are not necessarily done by bricks. You know?
Oh.
Yeah, even whatever we have done here, the partitioning walls are machine cut stones, but 100 millimeters thick. Yeah, but then we can as well use 100 millimeters thick for external walls, only when now the structure is a frame structure. When now we don't need them to be load bearing. You know, when we just now need them to be infills to enclose the space, we can work with 100 millimeters thick. But then when now the walls are carrying the load of the building, they just have to be 200 millimeters thick with a certain specific strength of the stone. So if you work with 100, it may not bear the load of the building.
So if I'm building my two-bedroom bungalow, for example, and I want to use those 100 millimeter thick stones, which will be cheaper? Nikitengeneza structure alafu niweke hizo 100 millimeter bricks ama nitumie load bearing ones niende tu nazo mara moja.
So when you do a bungalow, you know, a bungalow is a one story.
Yes.
Ground floor, unachapa roof.
Yes.
So you know, the roof also has weight.
Yes.
As you go up, you will reach a point where you have a ring beam. This ring beam carries the weight of the roof. And then, if it is the walls that should be load bearing, it transfers that weight to the walls. So if you do 100 millimeters thick wall, it may not have enough sufficient strength to hold that roof that we have there. You see, but when you do 200 millimeters thick with a certain strength as designed, it will be able to hold. So with the time, kama umetumia 100 for external walls, you may be experiencing cracks. Unashangaa ni nini kumbe, it cannot withstand the weight. So normally, what you need to do, if you cannot do a frame structure where you do the columns, the shikilia ring beam, then you do the infills, you have to do load bearing walls to support the rib.
So you'll save more when you use the load bearing walls as opposed to use now
the columns.
The columns for a two-bedroom bungalow.
Yeah. But then you have to, it depends as well. If you want to do maybe a four-story building, it is recommended you do a frame structure. Because load-bearing walls cannot go for large spans. Spans means the distance from one side of the building to the other. So it's recommended you do a frame structure. But then when you're doing a bungalow, you can just do your load-bearing walls and then you do your roof.
Mimi niko red, yangu iko wapi? Yangu iko wapi? Ndio hii. Very nice. Ugali ikiwa peke yake. Very nice. Very nice. Let's take a short break. We'll be right back. That was a well-deserved break, huh? Now that we are done with the food expert, let's get back to the walling expert. When the structural integrity of a building is compromised, dalili ya kwanza sisi huona ni kwa ukuta. Is it that the problem is always the walls? Juu pia zile buildings zimetuonyesha character development huku Nairobi zikicollapse. Unaziaga tu kusikia mtu anasema na tuliambia landlord tunaona crack mahali yaka ignore.
When you see a crack in a building, it may not necessarily be the wall cracking. You know, a wall consists of the wall itself, then there is a finishing, the plaster. Your plaster watu wanasemanga. So wall crack, you may see the crack, but then it's not the wall cracking, it is the plaster. The plaster cracks because mainly they didn't have enough time to cure it, so ikupata that enough strength alafu in a crack. But then what can cause the wall to crack mostly is called differential settlement of the ground. Ni ile yenye amkufanya geotechnical investigations vizuri for the soil to determine. Sasa hizo ni nini sasa jameni? Ile the capacity of the soil to hold the building.
The weight of the building.
The weight of the building. Now before they do the designs, they go and investigate the nature of the soil to determine the weight. So if it was not done well, you will do your design, but then you realize, you know, when you do the building, after sometimes it sinks.
So
the building sinks.
Kuna weight ya building unafaa kujua itakuwa ngapi?
Yeah, that's
depending on sasa ile mchanga unatumia mali.
Yeah, when you design, you have to consider the soil.
Okay.
So engineers watakuwa shapiga hesabu zao wanajua hii building itakuwa a certain weight. Can this soil hold that building? So it better determine the type of foundation they will use there. So if the soil is weak, you'll find that what I was talking about, differential settlement, this side of the building ina sink sana kushinda hii side ingine ya building. Unaona? Because when you do a building, every building when it's constructed, it has to sink a bit with some fraction. They all sink, they all go down by some distance, yeah? Yeah.
Over a period of how long?
It takes time. It takes a time, but then after some time it reaches the maximum point, yeah? So what happens to that building that we see them cracking, side moja, it may sink more than the other. The sinking should be the same, so that when this side sinks, they sink equally. So if you sink mbele ya hii, there will be that differential settlement causing cracks along the wall, even it can interfere with the structure. Yeah.
Now, what about a building that has a stone foundation but has wooden walls?
Wooden walls.
Yeah. Hiyo hata hiyo pia ina sink, ni foundation inafanya isink.
See, foundation inafanya isink, just the general weight of the building, its own weight plus now the live weights of the building. Own weight ni hiyo like uzito yake yenyewe. Then we have now the live weights or live loads. Furniture mmeingiza ndani, people coming there, they also add the weight to the building. So with the time, the building sinks or it settles, inaenda chini kiasi.
This is something that engineers always know, that the building will always sink.
It always sinks.
Mimi naisikia mara ya kwanza.
But then it doesn't sink like with the 1 meter or it's a small fraction, but it has to go down, yeah. But then it also depends on the type of soil down there. So if you're working on clay soil, you cannot build your foundation directly on clay soil because it has got a very high differential settlement range. Yeah? Clay soil will sink far deeper than the normal red soil. Yeah? So what happens when you construct in clay soil? They first do mass excavation of the whole clay soil until they reach a stable ground. So now that's when they start excavating for the foundation. Yeah. Lazima itolewe yote.
So in most cases where we see buildings using machine cut stones, it's probably because they already have the structure.
They already have the structure, so they just use it to enclose the space. Yeah, and then they will come and plaster it later. As construction continues, there is emerging trends in construction of walls.
True.
For example, there are other types of wall as opposed to the conventional ones where we use the stones. So for example, we have walls called EPS walls. They're called expanded polystyrene walls. These walls are not used for load bearing. These walls are just used for infill. So when you do your structure, EPS, that white material, I don't know if you know it, inafanana na that. You see that soft sponge where ukibuy TV, you find a white thing down there.
It's styrofoam.
Yeah, that form, yeah.
Yes.
So for construction, it's normally denser. That is called they're sold in panels, around 1.2 by 3 meters. Yeah. So what happens with the EPL panels after you've done your frame? you come and put meshes on the faces of the EPS. Then you come and drill holes in the beams. Then you insert in the beams. Then now you do a rough cast. A rough cast is like a finish. Then after the rough cast you do a plaster.
What gives them the stability? Because kama unasema ni hiyo kama hiyo ya TV, hiyo unachapanga tu ngumi hivi.
So for EPS slabs, EPS slabs they have to consider the strength. EPS slabs it's not like the walls, because the walls are not load bearing. For the slab they have to be load bearing. So they're normally in profiles. Unapata umeenda somehow hivi, then there are ribs in between. So in between the ribs, now they put reinforcement bars, just like the normal slab. After they put the reinforcement bars, they link them together, the panels, they link them together with the bars. Then now they will pour concrete on top of it. They're also connected to the beams, because you know ideally the slab has to transfer loads to the beams.
Yeah.
So they just do the normal slab like the normal to hold it. Then they set it, they do the reinforcement along the ribs, they set the concrete, and
so
then they do the final finish.
Ni huko ni za chuma.
Yeah, machuma.
So hizo chuma ndizo zinashikilia, basically ndio zinafanya kazi ya kushikilia. Hii ni ya kushikilia tu ndio plaster yenyewe itaelewa juu.
Then they do it down there.
Okay.
So then another type of wall apart from EPS, we have solid panels, concrete panels. This one is mostly done on perimeter walls. They're normally horizontal. They do the columns, then they set them horizontally. Mostly these ones are used to save on time, because you don't have to come and start casting the walls, doing the mortar. You just come with the panel, you set it there, prepare for the next level, and then you set it there. They're normally interlocked to the beams. So they normally save on time, but cost-wise they're higher, they're more expensive than the machine cut. But if you are aiming to save on time and proceed to the next step, it's advisable to implement such methodology. Yeah.
Okay.
Then again, we also have concrete blocks. Concrete blocks, these are just like stones, but they're not stones. It's a mixture of cement and sand given a shape to form like a stone. So the methodology for construction is the same as the masonry wall. So when they come, they just do the mortar, they lay the DPC, then another layer of mortar, then they start casting.
Now I'm realizing there's a lot more to walling than I just thought, because first there is a structure which is a whole, I'm sure tukiingilia ni chuma gani zinahitajika kutumika kutengeneza hizo. Actually acha tuingie hapo kidogo. Ni chuma gani zinafaa kutumika kutengeneza, kwa sababu ukuta clearly sio just the stones themselves. Yeah, there is also the chumas, the steel iron rods that are being used on the structure. So
rods are not used in constructing walls, unless there are also concrete walls, by the way. Those ones now we can use the steel rods. But now, whenever you're casting columns, the ones I was talking about initially, the type of reinforcement to be used depends on the strength that the building needs to hold and how far it needs to go. So if you look at the strip foundation, for example, let's say for a simple structure like a maisonette, normally they will do D10s. D10 is 10 millimeter diameter of bars along the strip foundation. Then we'll have links interconnecting them. So the links will be the 8 bars. Then we also have column bases. Column bases is the element now that holds the column. Column is mamangitu directly on the ground. It comes then rests on the column bases. So the column base also has to be reinforced with bars. So these bars.
Wait, so what I'm hearing you say is that the chuma hazitumiki kushikilia building, zinashikilia the concrete too. Concrete ndio inafanya hiyo kazi ya kushikilia.
For now, concrete to achieve maximum strength, lazima ikuwe imeshikiliwa na machuma. You know, if you cannot do a large span of concrete without reinforcement, it will crack na itaanguka chini. So what happens? They do layers of reinforcement na kushikilia to give it the grip and increase its strength.
At which stage does this happen? When the walls have zimeshikanishwa already, zimesimama, zimengojea siku kadhaa, zimekauka, ama ni unaenda ukiendaga?
Unaenda ukiendaga. You have to give the wall some time to attain that strength. Unajua mortar pia ni concrete, iko na cement and sand, and you have to give it some time to attain that strength. unaimwagilia maji for let's say at least 7 days. So after 7 days, after it has attained that reasonable strength, now that's when you go and start chasing.
The process of curing, ambayo ndio umesema ni hiyo kumwagilia maji etc. How important is it and what is it important for?
The major function of curing is to give the mortar the strength to hold the walls. They normally say concrete kokoto inapenda maji. So when you pour water on mortar, it absorbs the water and attains that strength. Yeah, inakuwa ngumu, so that it can bear the weight of the stones. So when you cure it for the required time, as you continue curing it, inaongeza that now the strength required to hold the wall. Same applies to the concrete. After you've cast and removed your formwork and struck off the formwork, you have to cast it for a period of time. Normally for 7 days, you can do 3 times a day for 7 days. Then you reduce the number of times, maybe 2 to 3 days. Yeah.
When I was going through the episode on the foundation, the engineer that I was speaking to talked to me about the foundation and waterproofing of the foundation.
Okay.
Is that process also necessary when you come to walling?
The procedure is they first construct the concrete wall. After doing the concrete wall, they do a protective screed on the wall. Then now they do the waterproofing on that protective screed. Then they do another protective screed on that waterproofing membrane. Then after that, now they lay the skin wall. That is called external waterproofing or external tanking. So when you do it internally, you'll do your concrete, then you apply the waterproofing membrane, then you do your protective screed or your plaster. So that will prevent water from seeping through. So waterproofing is done both horizontally and vertically. So when you do it horizontally to the basement, to the raft foundation, you will do your blinding, then you do a protective screed on top of the blinding, then we lay the waterproofing membrane, then after that we do another protective screed. That's when now you start doing your metal work, then now you do the formwork and then you cast. Then in between the vertical walls and the horizontal raft, there's normally a layer done between. It prevent water from going
up to the wall.
Yeah, it's called a water bar layer. It's normally blue in color, done between the vertical concrete wall and the raft. So hapo kwa joint, it's normally a weak point between the raft and the raft foundation and the concrete wall. It's normally a weak joint, so they do a water bar between there. It will prevent water from seeping outside and also coming to.
Niwekelee tu.
Niwekelea tu juu.
Aya. Hivyo. Sasa nitajuaje kama nimewekelea vizuri?
Unaangalia sasa. Unatumia saa kabiro.
Haya, kazi kwangu. So ninawekelea hapa. Ikiteremka chini. Leta. Mawe iko straight. Imelala upande wa nyuma. So ninafaa kusukuma mbele kidogo. Haya, hapa imetoka nje kidogo. Haya, so ninaweka juu kabisa. Iko aje?
Hadi kwa ile moyo chini, teremsha hadi moyo chini. Hadi kwa ile
hadi moyo chini kabisa.
Hiyo.
Hapo.
Finally, I get presidential treatment. I have put my cornerstone ama foundation stone. I do not know. But at least I have put down a stone. Now I'll come back and put a placard. Martin Gevenji was here. And it was here that we learned about walling. See you in the next episode. I'm Martin Gevenji and this is Tujenge. Build it better.